So now we come to the concept of homeostasis. Homeostasis literally translates as same standing still or unchanging. However, what homeostasis really means is that the body is actually constantly adjusting to external forces and yet trying to maintain its own balance. I know it's a lot to kind of think about. It is a fundamental principle of physiology, though, and it's one we keep coming back to every single system of the body, every single chapter. We have to keep coming back to this. So it's really important that you get it, that you understand it. So, again, lots of examples. So homeostasis is the idea that things are not completely stable, completely standing still at all times. However, they do tend to exist around a certain level of parameters. We have what we call a balance. A good example of this is glucose. Blood glucose, blood sugar, your standard blood sugar, is supposed to be maintained around 90 milligrams per milliliters, as you see here. However, you'll notice that it's almost never just 90. If you have just eaten a meal, your blood glucose levels will go up. If you haven't eaten in a while, your blood glucose levels will go down. And either way, though, you'll notice that it pretty much remains around 90, but it's not exactly 90. It's not exactly 90. So that's the concept of homeostasis. Let's talk about what occurs with what we call a feedback control loop. The idea of a feedback control loop is that the body is always striving for a particular balance. And this is what it looks like. There's a lot to look at here, so we're going to start off with just one part of this. The first thing I want to introduce you to is the concept of balance. The balance this is the thing we're trying to get back to. This is a variable. A variable, this is your first term actually, a variable is the factor or event being regulated. Sometimes the variable goes up a little bit and sometimes the variable goes down a little bit. For example, your blood glucose might go up, your blood glucose levels might go down. Your body has to decide what to do with this. Okay, so a stimulus is some sort of an external or perhaps an internal situation that produces a change in the variable. And then you have a receptor. There will be a receptor somewhere in your body that will sense that change. The definition of a receptor is a sensor which monitors the environment and responds to stimuli. From the receptor, then, we have what's called an afferent pathway. The word afferent is actually pronounced afferent, usually, but I always put an emphasis on that A. You'll see why in just a moment. When you think of an afferent pathway, you're going to be thinking about approach. And in this case, what we're approaching is called a control center. So this afferent pathway allows us to have an input into the control center. And then we have our control center. Our control center analyzes input and determines a course of action. Look what happens next. We have another pathway called the efferent pathway. Remember how the afferent pathway, you want to remember the keyword approach. For efferent, you want to remember the keyword exit. So approach and exit. You're going to be coming across afferent and efferent often. So I always put an emphasis, just my own lectures, I put an emphasis on the A and the E just so that we differentiate them because there are very important differences, of course. So the efferent pathway is the exit from the control center. The afferent pathway is where you have information sent along a different pathway. In this case, it will be sent to an effector. An effector then responds to the input from the control center, and as a result, you have a response. The response of the effector feeds back. Listen to this one. The response of the effector feeds back to reduce the effect of the stimulus and return the variable to the homeostatic level. Blah, that's just a lot of words. So it is essential that you think about blood glucose and you think about other variables in your body that are changing all the time. Body temperature, blood glucose levels, maybe just think of practical examples in your own home or maybe driving your car, how you're always kind of trying to stay in the middle of the lane. You don't want to go too far to the left or the right. Just think of examples and place the examples. Try to think through all of these little pieces of our feedback control loop and try to put your own example into here and try to understand how each of the pieces fit together.